Okay, so now I'm going to break down the regularized logistic regression program. As always, we start by making the imports of our libraries, and this time we're going to use this SIPE special, which is the sigmoid function. And some of the key difference between the linear regression is that between the linear regression and the logistic regression is that we get we predict continued values instead of. Okay, so now I'm going to break down the regularized logistic regression program. First, as always, we import some of our libraries. We already know NumPy, Pandas, and MATLAB. And this time we're going to use SciPy Special, which is the sigmoid function library. And by I'm going to make a small comparison between the regularized logistic regression and the linear regression that we already covered. The logistic regression has the goal to predict class probabilities instead of predicting continued values. We get an output between 0 and 1 in this case instead of a real number like in the linear regression. And in this exercise, we're going to have an activation of the sigmoid function, and the cost function is a logarithmic loss. And in the use case between the linear regression and the logistic regression is principally that the linear regression tries to predict trends, and the logistic regression is a classification program. Okay, now the components of this code, we already know how to upload the data using pandas. We normalize our values. We use an intercept for these values, adding zeros and ones, and then we get the at the column intersection terms. Okay, making the backbone to our calculations, and then we start the initial parameters for theta. We get our cost function with regularizations, and in this specific function we get the measures of how well the model is predicting, and we also get the lambda control right here that regulates our strength for the overfitting that we already covered in the linear regression. Also, we can see that we're using right here the value or the sigmoid uh, function. Also, in the gradient descent, we are going to make use of the same function, but in the gradient descent, we already know that we update the weight of our values and to minimize the cost. And the regularization terms, right here, regularization terms per are the ones in charge of changing the value depending on our weight or our cost. Then we get our predictions in the define predict right here using x and theta, and make an return in a probability scale instead of a value. Then we get our predictions, make the read data for our sample. So if we run this, we are going to see that the function and the values right here. So in this case, there's not a gradient descent so smooth because the learning rate is too small. So it's a slow learning process. The iterations are in a smaller range than usually. So the convergence may be slower. That's why we see the value decreasing ever so slightly. And lambda regularization, or the strength in which we regularize our values, is high. And by high, I mean bigger than zero. And by having this value, there's less overfitting, but it may underdrift. So if we take that value and make it smaller, like this, we can see that it might be better fitting, but I think in this case it might be overfitting because is smaller. Well, after the first reduction or after the first run, we can see that the accuracy of the model is to a 99% average, and we stay at that range. Maybe if we change the learning rate to something bigger and make the duration a little bit lower, we can see a change in this rate. After running, we can see the gradient descent being a bit bigger, and we stay at the 99% model accuracy. And this time I'm going to make the lambda regression a little bit over, a bit over what we are used to. We're going to see a gradient descent really close, and we are still at the 99 value. Okay, what if I make the learning rate bigger and the duration bigger too? Let's see. It's going to take a little while, but in this case, there's nothing smooth about this graph, and we keep getting that 99% model accuracy. So our accuracy is meant by the mean between the prediction and the target test. In the target test, defaulting to the values and the accuracy or the prediction being the value of predict function. There is right here two values using this sigmoid function